Good day to our lecturers, Dr. Sani. I'm Lawrence Kui-Hang. I'm from Programming Classes Section 1. So today I'm going to present about my individual assignments. So for today's assignments, I choose to calculate the maximum velocity in the venturimeters and the power to overcome the heat losses for the fluid mechanics fields. So the problem statements of the individual assignments is: can the maximum velocity determined, and what is the power required to overcome the heat losses, and what is the importance to calculate the maximum velocity and the power required. As we know that the velocity can change the pressure inside the pipes. So when the velocity is low, the pressure inside the pipes become high, and if the pressure in the pipes is too high, and the pipes cannot withstand, it will cause the pipe to burst. And when the velocity is low, the pressure inside the pipe is become low, and when the pressure is low, it will cause the water flow-ins or the fluid flow-ins will evaporate and become the gases, and will cause the cavitations which trap inside the pipes and cause the pipes to worn out. And this is why we need to determine the velocity inside the pipes to prevent this happens. And for the powers to require is because that the heat losses happens because of the fluids and the frictions between the fluids flows and the wall of the pipes. And if the heat losses frictions is high, the water flows cannot be constant, that it will decrease the performance of the machine. That's why we need to know the power needed as an external power source to maintain the flow of the water is constant to ensure that the machine is in the optimum conditions. So for the objective, we need to apply the knowledge of the C language into the engineering fields, and we need to learn how to write a program using the software compiler, which I'm using the CodeBlock compiler. So the third one is to learn how to solve the problem relative to fluid mechanics. So for the assignment, the methodology that I'm using to calculate the Vmax and the power is the Bernoulli equations and the power equations. As you can see, this is the general equations of the Bernoulli equations, and I convert it into, take the V2 as the value I want to find and convert it into these equations that I put into the programs. And for the power equations, the power equals to the volume flow rate, standard dynamic, viscosity, and the heat losses. And we know that the volume flow rate is equals to cross-sectional area of the pipes times the maximum velocity, which related to the Bernoulli equations. So for the initial value of Vmax and the powers, I calculate it by assuming the diameter is equals to 0.1, the pressure drop equals to 10 kilopascal, the velocity equals to 1 meter per second, the distance between the inlet of the venturimeter pipe and the distance I want to find is equals to 1 meter, and the heat losses equals to 1 meter. After I sub into both equations, I get the maximum velocity is equals to 4.43, and use the maximum velocity sub into the powers again, I get the power is equals to 341.32 watts. So this is the flow chart for my software. As you can see, I set the assumption for D equals to 0.1, the gravitational G equals to 9.81, the pi value equals to 3.141593, the maximum velocity and the power is calculated using just now the equations. So I get the user input the diameter D for the parts that they needed, and the pressure drops, the velocity, the length, and the heat loss the user inputs. So for the first for loops, I set the limit P equals to 10 and check if P is smaller or equals to I, it will go, if yes, it will go to the second for loop, which V equals to 1, and it will check if V is smaller or equals to J, it will go to the third for loop, which E equals to 1, and E is smaller or equals to K, it will go to the fourth for loop, which H equals to 1, and it will go down and check again if whether the H is smaller or equal to L. If it's yes, you will do the equations that calculate the velocity and the power, and you will check again if the velocity that calculated is greater than the Vmax that I set just now, it will go back for the increment H++, and until it get the answer is no, it will the Vmax will equals to the velocity found. And for here, if the H is no longer is greater than the L, you'll get the result is no, and you'll go back for the increment for the E value plus plus and go back. And same go for the E value. If E is greater than the K, you'll get the answer no, and you'll go back for the increment for V plus plus and so on for the V greater than the J, and you'll go back for the P plus plus and go back to the equation here. And this is the for loop. And if the P is greater or equals to I, and you get the answer no, you'll go into and display the value of the Vmax and the power. And here, when the Vmax is greater or equals to V2, you'll display the Vmax and the power, and you'll go to the end. And this is the overall process for my programs. For the result, this is the software that run and calculate, and it calculates the value 4.43, and the power required is 341.32. And compared to the calculation that are using the equations and by using the calculator to calculate, we can see that the answer is the same for both. And for the another one is I get the user input from user input, and for D equals to 0.1, the P equals to 100 kilopascal, the V equals to 15 meter per second, and the L equals to 5 meter, and the head loss equals to 3 meters. And I substitute all the values inside the both equation, the maximum velocity and the powers. I get the answer are the same, which is 7.95 velocity maximum for it, and the power is equals to 13831.31, which is the same as the program that runs. So as a conclusion, that today the objective for today's assignments has achieved that we learned that how to apply the knowledge of C programs into the engineering field, which is the fluid mechanics that I'm using right now. And the second one is we learn how to use the C compiler, to write programs, and we also learn how to convert flowcharts into the programs. And the value of the maximum velocity and the power can be determined by using the C program. That's all from me. Thank you.